Hello and welcome to this. We're calling it episode 51. It's kind of episode 50 part 2 of SlimDevOps Live. This is a continuation of what I was doing this morning, where I'm trying to make an Ubuntu derived operating system for the Raspberry Pi that's optimized for making and building containers. So we did that stream earlier, and we got some progress on that, some good progress on that. But next is to try and fix the problems that we've encountered, make it better, and actually try and measure in some simple ways to see, are we meeting our goals? Anyway, I'm delighted to say that Primoz is joining me. Hello, Primoz.
Hello.
How are you doing?
Hello. I'm doing fine.
So you're here to keep me honest. So
Something like that.
and also to help me when it all gets a little bit tricky and complicated. Now, if you're watching this on YouTube after the fact, this is originally streamed on twitch.tv/SlimDevOps. We stream there at least once a week. We do an office hours type thing. We do these ridiculous how hard can it be type challenges as well. And that's what we're up to here. Now, the goal of this one, I think, will span a few streams. Making an operating system for the Raspberry Pi, so the host operating system. And once we've got that far and proven that we've actually made something that's smaller and more efficient, that's the hope at least, we need to see if that's the case, then take what we've learned and make some base images in a similar fashion to create tighter, leaner, Ubuntu-based base images. And then we can get into the business of seeing how many instances can we run on a Raspberry Pi? Can we slim it with Docker Slim? All of that sort of stuff. And see if we can chase a world record maybe in the future as to exceed the number of instances of a web server running in a container on a Raspberry Pi. So some fun and games to be had.
Didn't Jeff Gerling do a couple thousand of them?
Did he? I know that.
He did.
I know that it was some years ago, but at DockerCon, about maybe longer, maybe like 5 years ago, somebody did this. I don't think it was Jeff, but maybe Jeff has done it since.
I think he did for some subscriber milestone.
Right, okay. Because his day job is working with, like, containers and cloud native stuff. So, and he's sort of, well known on YouTube for being... a Raspberry Pi enthusiast and insider. So that makes as a good match. I'm not sure if we'll be able to achieve that. Maybe I'll get in touch with Jeff again and see if maybe he can come and join us. Maybe I can bait him into into doing that. So let's pick up with what we were looking at earlier. So I hope all of these buttons work. Yes, they are working. Right. Okay. So that's I've warmed up the cache, you'll be pleased to hear. So let's go and take a look at what we were working on earlier. And I'm just going to comment all of this stuff out, because now I've warmed up the cache before we started. It should mean that when we rebuild things, it'll be a lot easier. So we had some problems. So we're going to have to start by fixing the problem. So what did we manage to achieve? We did indeed make an image for a 64-bit Raspberry Pi based on Ubuntu that booted and ran and did things, and it has currently got Docker pre-installed, and Docker came up correctly, configured its networking interfaces, all of that good stuff. So we have a functioning operating system, but the bit that pokes the ARM64 bootstrapping information into the bootloader wasn't working, so we need to fix that. There is no networking by default, so we need to fix that. And it turns out I thought that it was just the lack of networking that was a problem, but there is no SSH server at all. So we need to install some kind of SSH server, because that will make our lives much better. We'll then make sure Docker Slim is provisioned alongside Docker itself, so that we've got some sort of essential tooling. Maybe we'll put some other bits on there as well. And then I think once we've proven that we've got all of that working, we have our initial POC. And I think what we should do at that point is go and take a look at how it compares with the genuine Ubuntu images for the Raspberry Pi in terms of size and footprint. So that's the plan, and then maybe we can move on to doing some of this stuff here to maybe tighten up on the Raspberry Pi side of things, exploiting the hardware such as it is as best as we can. So did you watch the stream from earlier?
Yes, I did.
Yeah.
Yes, I did.
What observations do you have, if any, about that?
Nothing really much. You did everything as I know how it should be done.
Oh, okay. Well, that's good. That's good to know. At least I didn't make any catastrophic errors.
And how I know how it should be done, I know from you. So it could be catastrophically wrong.
Oh, well. Yeah, that could be tricky. Yeah, I mean, yes, I've learned this by doing, so I'm not sure all of it is necessarily 100% correct, but we'll see how we get on. So let's go and fix a couple of these issues very quickly. So the ARM one is quite a big one. We need to fix, otherwise the thing won't boot. And I've thought of a simple solution for this. So in the configuration stage, which is here somewhere, up here in fact, golly gosh, where is it? There it is. Here we go. I was trying to do this sed replace, but actually I've thought that a simpler thing to do would just be, say, if we're building on ARM, then simply echo that out to the appropriate place. So, because we just need this line in there, we don't need that sed anymore. We will need to check the current config.txt to make sure that it's in the correct context. I'll just explain what that means in a moment. So here we can remove that stanza. Yes, it is. So after something specific to the compute module 4, should we have been running on a compute module 4, we set this context back to all models of Raspberry Pi, which is what we want, because we want this to be interpreted correctly. So apply ARM64 tweak. So if it's building for ARM64, poke those in. I think that will do it. That will do it. So that's in the config. Oops, I didn't want to go there yet. That's in the config step. So we'll close. No, we'll leave it open. We may need it later. So I think that should be this piece fixed here. So the next bit is, let's see if we can actually have a network, because that would be good. And what we're going to do is use NetPlan for that. So given that NetPlan is installed in, I'll put it in the configuration stage, because then we can build from quite late on in the process. So in here, in fact, we will do this. We will copy. Let's have a look. In root etc NetPlan, there we go. So that's what we'll copy from there. Oops. We'll copy that, and it's config.yaml to where we're building the root file system, and that may or may not exist. So what we'll do is make sure that that directory we want to copy things into is there. So there we go. That will do that. So this, and here's our configuration file for NetPlan. NetPlan's been the default network configuration tool in the Ubuntu server images for at least 2 releases, maybe more. And because of the way that we configure the Raspberry Pi to always have a predictable ETH0 as its Ethernet port, we can drop this file in, and it basically says use systemd network D as the network renderer, and we are defining that we want to be getting a DHCP IPv4 dynamically assigned address. So that should take care of our lack of Ethernet problem. We're making the etc netplan directory, and I need a slash there. There we go. And we're copying that configuration in. So that should mean the next time we boot this thing, we actually have functioning Ethernet, which would be nice. And then we've got the SSH server. Now, Big Pod, I'm going to ask you for your opinion here. So we'll come back down. Well, we'll come to. We'll probably have to do this in the bootstrap stage, but I'll do this in the configuration stage so we don't have to keep rebuilding from all the way through. So here's our options. We could use tried and tested OpenSSH, which is the sort of de facto SSH solution, but it's a little bit heavyweight on memory. But the one advantage it does have is that because it uses a systemd unit to bring it up, it will actually wait for a connection before it actually starts the service. So it won't be sitting in memory until we actually connect to it. But once we do, it's going to be hundreds of megabytes of RAM. Well, tens probably initially. Or the other option is to use Dropbear, which is an SSH server for embedded systems. That isn't brought up by systemd, so it will be running all the time, but it's teeny tiny. Very, very small indeed, but completely compatible with like all the stuff we'd need to do. So what do you reckon? Which do you want to go for?
I think Dropbear would be a better option.
Yeah, I think so too. So we'll actually do the install here and we'll move it up. So we're going to do an apt-get minus. Oh, hello, look at this. Apt-get install. We don't need the recommends bit. This is Copilot telling me what to type again. I'm liking this a lot. So we'll do that, and then we will copy the Dropbear configuration that I have prepared over the top. So here's our Dropbear config. This is basically taking the default configuration that you get from the package, and I'm changing precisely one thing, which is this, the extra arguments. And these two arguments do two things. The first is the very first time somebody connects to SSH, if the host keys don't exist, it will generate the SSH host keys, which means we don't have to have a systemd unit to do that on first boot or anything like that. And this -w just basically says forbid anyone trying to log in as the root user. Regardless of how they're trying to log in, root connections will just get kicked. So those are the two options. There's only a handful of options, but those are the two that we're going to go with. So what we'll then do is we'll copy root etc default Dropbear into etc default, and by default Dropbear will automatically start on boot. So it's one of these services that uses the old style init process that's now managed by systemd, but it's not a systemd unit, or at least not in the current packaging. Maybe we could change that at some point. override the initd and create our own systemd unit, so we get the benefit of, if you haven't connected over SSH, the thing isn't in memory in the first place. So I think that's everything we need for an SSH server. And we're definitely not going to need... No, I'm going to leave it, because if I say we don't need it, it's almost certainly going to go wrong. And we will need it. So
well,
the other thing...
this is supposed to be a development server, so running a SSH server on all the time makes a lot of sense, since there is a chance users will use it as a remote device, not connected to their
and that's something
monitors.
I'd like to have a look at, is like maybe hooking up, like, you know, Visual Studio Code and the remote development stuff to this, and, you know,
actually pretty easy.
So
SSH.
maybe we can have a look at that you know, next week sometime, because I'd be interested in looking at that and getting it all integrated and seeing how it all fits together.
I use Visual Studio Remote all the time, mostly with containers, but it's pretty similar process for SSH.
Can I pencil you in for that then sometime next week?
Sure.
Brilliant, that would be great. I wonder if I can get a Raspberry Pi to you by then. I've actually had 2 delivered yesterday, so I might be able to get you one now.
I would be so happy. I still can't get a Raspberry Pi.
It's
been looking
had 2 Raspberry Pi 4s with 4 gigs of RAM arrive yesterday, so I'll see if I can get one of those to you. Right then, so Docker Slim, let's go and install. In fact, what I was going to do is, let's just go and find that drop bear piece, because what we should probably do is move... I'm just going to leave this where it is for the moment, but what we could do is this. In the bootstrap stage here, we could simply add drop bear in here. So let's just check that that's a sensible thing to do. I think drop bear's only got dependencies, no recommended packages, pre-depends on init systemd and depends. That's fine. So we can put that in there. So on subsequent runs, drop bear at least gets installed by default early in the process. I'm putting it in the configuration step for now, because I don't want to have to go back to too early in the build process. So what we should do here is install Docker Slim. So we'll need to go to... I need to change my browser settings. This happened earlier.
Just click on the cogwheel and select no news.
Yeah, well, the annoying thing is that I did spend some time configuring all of that, but with an upgrade, it has decided to conveniently forget my settings.
Sometimes it forgets settings. I use it all the time, and it's kind of pain with that. So
here we go. We'll use this. We'll embed this in our shell script, our build script. This was something I contributed to the Docker Slim project. So we should already have curl by virtue of installing debget, and actually debget kind of this script for Docker Slim was kind of where the origins of debget. You'll notice that they've got the same evaluation logic in them. So we're going to do that curl, and then we don't need to pipe it through sudo, because we're going to do this inside the container where we're building the root file system. If I could just type the words. There we go. So that's going to run inside the container. It's going to download and install the current version of Docker Slim, I hope. And again, what we'll do is we'll just drop this line into the configuration step here. It's not the boot process. It's close. It's the build process. Oh dear. I never tire of this. So that should give us Docker Slim. So let's tick that off the list. And if we rebuild our image from the config stage, we should get a new image that now has all of those fixes stroke improvements integrated, and it shouldn't take too long because there's not much to do. So we'll rerun our build script to tell it that the architecture is ARM64. Let's just make this a bit bigger. There we go. Let's go. So this shouldn't take a huge amount of time. It's only got a couple of small packages. So that's Drop-Bear being installed. There's the keys being... that's something we need to do. In fact, that whizzed by super fast. I think we're almost done. There we go. It's building the image now. So if we just scroll back up here. Command not found. Running command not found. I think that's my thing trying to install Docker Slim. So what did I do wrong there? Can't remember. Let's go and take a little look at that. We'll fix that.
That I think is
there we go.
ripped.
I have got the thing to clean up the host keys that get generated in the build process for Drop-Bear. Oh, this I need to look at as well. I don't know if that's going to work. So where were we? Drop-Bear. Let's just look at how I'm doing the deb-get. So I'm doing it slightly differently. Oh, I see. I did it like that. Okay. Okay, so we could do the same thing. So let's go and so end spawn. It says it couldn't find curl, didn't it?
No, it was some numbers.
Yeah.
Which I think is something in the script itself that's wrong.
The script works when it's not being oh, I know why it is. Yeah, this is the issue. This won't work because I can't use pipe inside of the end spawn. That's the issue. So there we go. So we'll drop this in here. We'll wget that.
You could just do -o output and the name of the file and then execute the file.
Yeah.
Or wget it is the same thing.
Actually, sorry. But
right now it's not required. With curl you can just do.
Oh, right, I see. So we'll do this. There we go. Look at that. That's Copilot again. Figured it out. Loving this. Oh! Look at that. It just prompted. There it is. There we go. It's giving me the correct prompt. Look
It's
at that.
learning from you.
I don't know how it's learning, but I absolutely love this. It's so good. So Shock 0572. First of all, welcome to the stream. Thanks for stopping by. That code prediction is GitHub Copilot. It's an AI pair programmer, and I've been using it. When was it launched, Big Pod? About 2 weeks ago. Yeah. I think it's been in beta for a while, but it was officially launched a little while ago. You know what it is? Okay, cool. So I've been using it since it launched, and I like it a lot. It's terrific. Yeah, because of the number of open source projects I contribute to, I got the come and use it as an open source, developer for free. So I took them up on their offer. Right then. That should install what we need, and what we'll do is take those lines and put them in this config stage so we don't have to run from the beginning. Oh boy, there we go. Right then. That looks sensible. I think so. Let's go and run that again. Oh, I missed it. Never mind. So the advantage of having drop bear build the keys, did that work that time? Cannot access no such file. Hang on a minute, that doesn't make sense. It set the permission and then didn't execute it.
You didn't even find that file. Even change the permission. As the change permission couldn't find the file.
Okay, well maybe what we're doing is sticking it somewhere in the wrong place. Let's do this. Maybe /temp doesn't exist inside the container. So as we're doing this as the root user and we clean up the contents of root afterwards, let's do that. Just want to be certain that that script is functioning correctly, because if it's not, I have a new problem, which is fix the scripted install script. But it should work. Okay, there's drop bear. That worked. There we go. There we go. That's got it. Okay, good. Right then. So we should have an OS, and I think what I'm going to do is at this point, I think we should actually stick a proper Ubuntu on an SD card, boot this dev box off proper Ubuntu, and have a quick look at how much RAM it uses, how many running processes there are, how much disk it's using, to give us sort of an indication of what regular Ubuntu looks like. And then we can try and boot this to see, does it still work? Do the fixes work? And what does the profile of the system look like? So let's do this. I've got a card reader up here on the top of the machine, and this is 128 gig SD card. So we'll drop that in, and we will start the Raspberry Pi imager, which I'm going to need to drag down here. In fact, I've already done this. This bit I've already done. I'll leave that there because we can use it later, but I've already put Ubuntu on this SD card. So let's get this booting up. Okay. I'm gonna hit start. And so this is Ubuntu, and as I said earlier, I'm quite familiar with how this is put together because I used to work at Canonical and had a hand in bringing Raspberry Pi enablement to Ubuntu, and also refining it, working with the Raspberry Pi trading. So this works a little bit differently in that this has cloud in it, which means that you can provide some configuration from the file system where the bootloader exists to configure your network how you want it for your environment, or provision your user and user accounts. So here you can see his cloud init running now, and for this project in air quotes, I'm not sure if I want to go to the lengths of integrating cloud init or not. So we're up and running.
Cloud init is pretty nice when you have VMs and stuff like that, or when you have multiple machines you're trying to provision to specific standard.
Well, if you're doing it for actual metal, in the data center, you can use something like MAS, which is Metal as a Service, and then you can pass your cloud init configuration into that, so it will do the sort of the bare metal provisioning, and then use a provided cloud init to actually do like your disk layout configuration, your network configuration, your firewall configuration, all sorts of stuff.
I think Proxmox, which is for VMs, also use cloud init.
Everything, well, I say everything, almost everything uses cloud init or has cloud init as an option these days. It's a Canonical project initially, bootstrapped by Canonical, but it's widely used. But I'm just thinking, for a Raspberry Pi, we're not going to have complex storage requirements. We don't need complex user requirements. We have a predictable network interface. Maybe what we could do is a poor man's cloud init, which is just basically go and look for a netplan.yaml file, and maybe have a systemd unit, which is in the very early boot stage, that says if there's a netplan configuration in the bootloader partition and there isn't a netplan configuration in place, go and use this user provided one. So at least you can do the network provisioning bit, which is probably as much as you would need. Maybe that and username, your default user, that would probably be the size of it. So that's something we could look at doing. So it should be up and running. Here it is. So if we log in as Ubuntu and the password is Ubuntu, it's now going to tell us we need to change our password. And unfortunately, I have to come up with a relatively long one, because otherwise it will tell me it's insufficient. So I can't use my trident. Oh, that was the wrong password. It was asking me for the current password. Let's try that again. Current password is Ubuntu. My new password is simply going to be SlimDevOps. There we go. There we go. Right, so here we are. We're in Ubuntu. If we do df-h, we can see that this is using 2.3 gig, and it's automatically expanded the file system as I would have expected. So it's using 2.3 gig of space. But if we just look in the root partition, what we'll notice is there's no swap. So if we query with free, there is no swap defined. So we need to remember that when we look at ours, because ours has an optimized swap partition being provisioned as part of the first boot process. So what was that? 2.3 gig. So we need to try and come in under 3.3 gigabytes, because we need to account for our swap partition. What else can we look at? Let's try this. In fact, let's go here and see if we can find this. So let's see if we can find this Raspberry Pi on my network. There it is. That's the same as earlier because it's the same machine. We will have to yank out our host keys from the known hosts locally because they've been refreshed. So let's log back in. Yes, we do want to do that. And our password was SlimDevOps. This should... Hello. Is it because I haven't logged out yet that's... Oh, it's Ubuntu. It's Ubuntu, not SlimDev. That's why. It's Ubuntu. This is the... Right, let's try that again. Let's try and log in with the right username. There we go. There we go. So this is a little easier because it's a bit bigger. It'll be easier for other people to see. So we get this rather fancy message of the day type capability. And what was I about to look at? Oh yeah, it was, what does the initial process tree look like? So we've got multipath, which is a tool for configuring complex disk subsystems. We've got some systemd stuff, all of which will be required. We have dbus running, IRQ balance, network dispatcher. I can't remember what that's responsible for. Policy kit, syslogd, that's fine. We've got snapd running, login d we need. udisks, again, that's a disk subsystem capability. WPA supplicant for wireless networks. Cron, unattended upgrade sitting around. Modem manager, which is curious. Then our terminals. This is the Bluetooth interface for the Raspberry Pi, so the actual Bluetooth device. Bluetooth daemon itself. There's SSHD, login, and some systemd user session stuff. So let's just take a look at, this is very broad strokes, but 191 megabytes. This is not precise or scientific. We're just trying to get a straw man measurement. So I should have made some, I know, I tell you what to do. We'll do it over here. We will go here. I'm pressing the wrong button. No, I'm not. This is what we need. So we'll just create a doc here very quickly. And we'll capture some things. So disk was 2.3 gig. No swap enabled. And RAM was 191 MB, which is actually pretty decent. It's not too bad, that. And I think what we'll do is we'll just do this. If we were to do, this is not scientific, 194 processes approximately. It's just a rough guide. $194. And what we could do is we could, for comparison's sake, if we were to do that, we could then just go and pick up all of these. We don't really, this is all kernel stuff. We don't really care about any of that, do we? No, I'm just gonna pull out what's actually useful. So from PID1. There we go. We've got that for reference. So there's our reference information for what we need to do. So we need to try and do better than 3.3 gigabytes because we'll have 1 gig of swap. And then there's the RAM and there's the process count. So let's go and see how our thing stacks up by comparison. Let's go and power off the Pi. And clear that and we got the imager running. Yeah, there it is. So now we will put there you go. There it is. We will now go and put our operating system. Well, let's call it. You know, I've kind of coined this thing as Slim.AI. A nice mix of sounds from when I used to work with AIX and when I worked at Sun Microsystems on Solaris and Sonos. I kind of like these mix of sounds and what have you. So we'll choose our custom image and we'll go to builds. Here is the image here. So we will open that and stick it on that card and go for it. So this shouldn't take too long. So what do you reckon? What do you reckon the odds are that this is going to work? Anyone in chat is free to cast aspersions as well. What's our likelihood of having it boot and all of the things work?
I would say there is about 75% chance of booting. And I think it's at least RAM wise, it's gonna be lower for about 15%.
15, did you say?
Yeah.
Okay. Right, well, we'll see how we go. I mean, another day I think we can do some more interesting benchmarks with that stuff. Right, there we go. So we've got our image done. Let's get rid of that. Pop this out of here. Oops, that's upside down. Right then, let's hit the power button and switch to the capture card and see, does this thing come up? Well, we've got a bootloader, that's good. Although last night I was going in circles, I couldn't get beyond the bootloader on something I was working on. So it's not always a guarantee of, you know, success. There we go. Right, so here comes our kernel at least. So we're going to have something. It's whether or not we have all of the bits and pieces set up and running.
What's interesting with the Raspberry Pi is that it actually boots from a GPU.
Yes, it does. Yeah. Right then. So we are now going to, we've got hard-coded username and password currently. It's in the build script. And glory be, my password is test. There we go. So the box is up. Let's just see if, there we go. An Ethernet is configured. So that's good. So at this point, I'm going to log in remotely, because that is then consistent with what we did on the Ubuntu box. We logged in on console and then we logged in over SSH. So this should be, you know, this is not an objective benchmark in any way, shape or form, but at least there are some scientific rules to what we're doing here. So we need to log into that, and we're going to have to throw our keys out. Oh dear, we're not running SSH by the looks of it. So let's go back to the console here.
IP has changed.
Oh, it has. Huh. That shouldn't happen. It's the same box.
Yes, but maybe the image.
Okay. Good spot. Good spot. Let's go and I'm gonna just close this app here.
The only reason it would change is with different MAC address, but I'm not sure how that could happen.
Yeah, I have a very unusual network configuration here. So this Raspberry Pi is actually connected to the back of my workstation using a crossover cable, and my workstation is its network router, so to speak. Because I'm in this shared office space, we only have Wi-Fi, and the Wi-Fi is isolated, so each guest on the Wi-Fi can't see or touch any other guest. So in order for me to create a LAN, I've had to connect it to the back of my PC. So my PC is connected over Wi-Fi to all of the things, and the Pi is sharing the Wi-Fi by virtue of a crossover cable. It's a bit janky, but,
done worse. I have done worse in the past.
It's serviceable. It works. It works much better than I thought it would, actually. So our password should be test. There we go. So we're in, and I've even added this for you know, the professional touch. Welcome to Slim.AI OS for Raspberry Pi, built with Ubuntu 22.04. So we're now logged in. Let's start with Dia. So we are at 3.1 gigabytes, but we have a 1 gigabyte swap file just here, in fact.
Yes.
So that means our file system, in simple terms, is 2.1 gigabytes. So yes, let's just catch that metric. So only 200 megabytes different. There we go. So let's go and look at RAM. Oops. 154. I'm quite happy with that.
Way more than I expected.
I'm quite happy with that. That's where it could pay dividends. 154 megs. That's quite good. And I think we can do better there as well. And then our process count. This is where it could get interesting. So let's just have a look. I'm going to move that keyboard to one side. I keep typing on the wrong one. So let's just see what our process tree looks like. It's not as dense, that's for sure. So there's PID1. Here's all the systemd stuff. I think this we have, which I didn't see in the Ubuntu one. In fact, let's just go and have a little look there. So the Ubuntu one, oh, it did. There they are, 1, 2, 3, 4. Oh, so it was separated with multipath D, which we don't have. Which is fine. It's intentional. We have dbus. We've got no package kit or any of that stuff here, though. We've got the network dispatcher running, but here we have. This is interesting. So we're less RAM, but we've got some differences. So where the snapd was installed by default in Ubuntu, we've obviously installed by default Docker. So we have containerd and dockerd running here by default. So I think I'm going to spot my first mistake. I think if I say do this, yeah. So what we haven't done is we haven't said to our user creation process, put this user in the Docker group. Yeah, so we'll have to do that by hand. There we go. We'll just log out and log back in again. Oh, that's the wrong password. My password is test, by the way. So now, hopefully, there we go. So we're now in the right group. So let's just go and add to the list of things we didn't get right. We need to add yeah, it got there. It got there. I was trying to out-type it, but it caught up with me. So if we come back to have a look at this, I wonder if we can Docker pull. Is it Hello World? Yep.
And it should run.
Let's think. I want to Docker run
IT.
IT, yeah.
Hello world.
There it is. That's good. So Docker images. So this works. Docker PS. Nothing left behind, which is correct. I wonder if this works.
No,
Docker.
it doesn't have plugins installed.
Ah, okay. So Docker Respawn won't work either.
No, nor Docker Compose shouldn't work.
Okay.
Try Docker plugins and see what happens.
No.
Okay, which means you installed the version without plugin support even.
So I installed Docker CE. So that's something we can go back and look at.
Yes.
Now, what I did do is I did install debget. So I could debget install sift and great.
Could it be that Docker for ARM doesn't support?
It's possible. I mean, this is all part of the discovery process. So sift and grape are available for ARM64 though. So I can work around this issue. I can get those tools this way. Hello, musical coder. Welcome to the stream. Thanks for stopping by here for the first time. I know I've seen you on my own channel. Good to see you again. So we should be able to do sift hello world. No. Oh.
Try. I don't know if it added the repository for Docker CE, but try installing with apt Docker Compose plugin.
I tell you what, let's do this. Let's do apt search Docker. Oh, how about Docker? Oh no, all of the Docker things are installed.
Try. That's strange because their repository should have.
Let's make sure that we have got. There we go. There is. I'm just updating the package list because in the image building process we flush out all of that stuff. So if we update the package list and maybe rerun that search, we might find more things as opposed to.
Was there Docker repository in there in the list?
There we go.
Okay.
So there's a lot of stuff now. Okay, so
and we have
Docker Compose plugin. That's what we want.
This one, and I think this will also pull the support for plugins.
So that's a good tip. So we should probably put that into our build script as well, because why would I not want Docker Compose?
Yeah, and it's the better version of the Docker Compose.
Docker scan. Hello.
But I'm not sure if Docker scan is in there. Try Docker plugins now or Docker plugin.
I will do. I'm just going to say add Docker Compose plugin, which was actually, what was it called? Docker-Compose plugin. Docker Compose plugin. There we go. Okay, I've kind of gone off piste a little bit here. I've got into sort of finding out where the issues are. But let's just, before we get back to the plugins, let's just do that. We've probably we haven't blown out the process count. Oh, but we have added package kit because I've just installed some stuff. Package kit D has burst into life, so we've actually disadvantaged ourselves. But we will do this 139, and we could actually say it's 138 because so actually I'm pretty happy with those numbers. Okay, so good. It's a smaller file system, it's less RAM, and it's fewer processes. So in a very simple way of measuring this, we can say we're achieving the target of creating an optimized OS for this. So
yeah.
We'll go with that. Let's go back to here. And you say, let's have a look at Docker plugins. It's not a Docker command.
The Docker help. It should be, because that is a plugin. Docker plugin. Plugins.
Oh, plugin. There we go. Docker plugin.
Yeah, I didn't know it either.
There we go. Okay, so we can install, inspect.
Install, list, all that, and
there are none. How do I find out what they are?
try dash A.
Like this.
ls-a.
So
Okay,
I haven't got any installed. So let's try Docker plugin install. Scan. Is that going to work? The response? No, it didn't like that. Authorization failure. SBOM. I'm guessing that this is what they must be called. No.
Let me see.
I mean, on my system, I didn't have to do anything clever in order to get these tools. So maybe I have to log into my Docker account or something like that in order to get this stuff. I'm not too fussed about that. So
let me see. Try installing Docker scan plugin with apt.
I'm just noticing another issue. Our path isn't suitably well formed. we'll have to work on that. Sorry, what was your advice?
Try installing Docker scan plugin.
Docker what?
Scan plugin.
N?
Scan.
Oh, scan. No.
That's what Docker website says.
Maybe it's not available for ARM. There we go.
It should be, because they have a build for Mac with Apple chips.
Yeah, that's a good point. Yeah, I mean this is part of why I wanted to do this. I was thinking, could I make a container on this for ARM64 and send it to somebody in the company who's using an M1 or M2 Mac, and that just work without any, fuss and complexity. So, however, sift and gripe work, albeit that I don't have user local bin in my path. So we need to do something about that.
I also want to start working on ARM images. That's why I'm actually looking intensely for a Raspberry Pi, so I can have something that is ARM that isn't Mac,
right?
Because that's gonna cost.
Yeah. What I'm wanting to do is I've got some projects that I want to test them on ARM here first, and then once I'm satisfied I've got things right, I want to then configure some GitHub workflows to automatically build ARM versions of the software to go into GitHub releases. But I want a place to test it.
What I've been using for last couple of times when I need ARM was AWS instance, but let's just say that gets expensive quickly.
Right. Yeah. And again, I mean, I know,
especially if you forget to turn it off when you go to sleep.
Yeah, and although Raspberry Pi are very difficult to get hold of at the moment, and therefore, if you pay scalper prices, they're ridiculously expensive. But if you in normal times, under normal situation, even an 8 gig Raspberry Pi 4 is like $75. The 4 gig I think is like 35. So a relatively inexpensive way, and actually the performance is quite decent. And if you put active cooling on the SoC, you can overclock them to 2.1 gigahertz up from 1.8 gigahertz. And I'd say the performance is sort of, if you imagine a desktop class PC from 10 years ago, it's kind of that.
I don't have to imagine. There is one right here pretending to be a server.
Oh, well, there we go. So, right, well, I'm pretty happy with
more.
this. We've definitely made something smaller. We've found a few nuanced issues. So I'm going to have a look at some of this stuff here. So here's some questions for you. I'm going to say I don't think Bluetooth needs to be enabled by default on something that is going to be a dev environment. I mean,
No.
what would I potentially I might want to connect a keyboard to it over Bluetooth, but would I
SSH.
actually? We've got SSH, we have Ethernet and SSH, so I think Bluetooth is a safe thing to turn off.
Yeah.
I would even argue we don't even need Wi-Fi.
Maybe because people do rely on Wi-Fi more and more.
Yeah, true.
Way too much, if you ask me.
Yeah, so we can leave that. And actually,
wired.
The only way we would disable that, because it's not configured by default, but we can disable it, at a hardware level in the bootloader, but we won't do that. And then this was one I was curious about, and it's a shame Takov's not able to join us this evening, because I was thinking, well, do we even need to bring up the audio interface on this thing? But Takov was telling me about an example where he has some container with like multimedia stuff inside it, and he's running this stuff on a Raspberry Pi. And so therefore the container needs to be able to get to the audio interfaces on the host in order to do its thing. So I could see that, like Volumio is a very popular app on Raspberry Pi, a music player service. So I'm thinking we should probably leave that alone. But we can probably ditch this.
Yeah. But I'm thinking maybe disable audio in a software so it can be easily enabled.
So the audio hardware is available, but we haven't installed the audio stack at all. So there is no, well, there is also, because that's kind of in the kernel, but there's nothing connecting to it. There's no pulse audio, no pipe wire, no jack.
I think that's okay.
Okay.
I thought there is pulse audio in, and
so let's
throw that out.
Okay, so let's do this by hand. We'll sudo system couple. We're going to disable HCI UART, which is the Raspberry Pi device, which is what the Bluetooth sits on the back of it. And I think it's going to be Bluetooth, and we'll say do that.
Might be Bluetooth D?
I think it's just Bluetooth. There we go. Bluetooth D is the process, but I think the unit is just Bluetooth. So that's brought down a couple of targets, and we should already see that we have fewer processes because there's no Bluetooth D and there's no HCI UART in there. So is it in profile? Where this stuff, I can't actually remember where the path gets set. Bash.bashrc, is it in there? Oh gosh, there's all sorts in here. So I suspect in my making this as trim as possible, I've actually removed something that sets the thing up. So we're going to reboot. We've made that change. We've disabled Bluetooth and the HCI UART, and all we've done is disabled that at the init level. So here comes the box. It's booting up again, so we can go and put those into our little configuration script as a little optimization. I'll be interested to see if that does anything measurable by the course way we're looking at this in terms of the RAM utilization. I don't think it's going to be significant. So oops, there we go. Let's log back into our so certainly none of that stuff is running. That's all good. So let's do this. 156. So no measurable change. That's fine.
Well, it's still better than what my desktop does, which is from completely cold boot 14 gigabytes.
Wow. Okay. Yeah, I mean, 156 megs not bad. I remember some years ago there used to be these little devices in times before Raspberry Pi. They were these things from, was it Netgear? It was Netgear or Netlink. It was somebody like that. They made these things called the NLSU2, and they were known as slugs, and they were ARM-based servers. And it had an Ethernet port and a couple of USB ports, and they were tiny, not much, about the same size as like a Raspberry Pi in a compact case, and they had 32 megs of RAM. And it was surprising back then. This is going back like, over 10 years, but you could get, using things like Dropbear and the iNetD services for things like FTP and even a trimmed Samba configuration, you could actually run a home server on these things into 32 megs of RAM. So it should be possible to get below this here, like, but I don't think it's necessary. I mean, we're gonna struggle because we are running Docker, right? So that's where most of our memory's going, and that's fine because we actually wanted to, have that. So I think what we'll do then is we'll just come down here and go into the configuration step again, and we will make those changes permanent for we're going to end spawn, system couple, disable HCI, UART, and Bluetooth. Now, if we do a systemd analyze and time, so it tells us that our kernel took 4 seconds to bootstrap. We can't really do much about that. And then there was an additional 12 seconds in user space. But we got to the graphical target. Now, we don't really care about the graphical target here. So let's just see what was taking up the time in this process, see if we can identify anything else. Because although the boot process is massively parallelized, systemd network wait online. Interesting. So we could probably disable that service and that would be fine. And we've got the RPi EEPROM update service as well, which, so this is an interesting one. Technically, you shouldn't need to use that, but I was looking at the Flatcar documentation earlier, and Flatcar have an optimized container OS. In fact, I believe it's the sort of successor of Core OS, and they have a Raspberry Pi version, but they have these steps to use regular Raspberry Pi OS to update the firmware on your Raspberry Pi 4. I've bundled those tools in this image, so if you were to actually start a Raspberry Pi 4 and you don't have the latest firmware, you can at least use this image to update the firmware on your Raspberry Pi 4. So I think that's quite useful. Anything here is so quick as to not worth worrying about. So let's say like the Docker sockets right down here in the real early boot process. That's amazing. So let's do systemd no, systemctl list dependencies for the graphical target, because that's where it wants to look at. And we're obviously not running a graphical target at all, but it will give us this tree of what the sort of dependency tree for the boot was. So this is all fine. Log rotate, fs trim. These are timers, so these are all things that, this is why we've disabled cron, because these timers exist by default. All of this is fine. There's nothing we need to change here. This is all essential stuff. App armor we absolutely need because we're running Docker containers. This is all fine. Systemd ask password. Okay. SSH regenerate host keys. That we don't need. That's a leftover in my build script that we can get rid of. So somewhere in here I will still have, here it is. We don't need that. That's not actually going to take up any time, but we don't need it. And we can get rid of that from our pool of stuff. There we go. So we don't need that because I don't even need to use sudo. It's local. There we go. So that's not, that would have been a few milliseconds maybe. And network dispatcher, drop bear we know about. There's Docker, dbus. So multi-user target. So actually drop bear is starting where it is because it's an init process rather than a systemd unit. So I think we could change the default target to multi-user because we don't care about when the graphical target gets reached. And I can't remember how to do that off the top of my head. Let's go and look that up because I can't remember how to do it. Oh, right, I'm going to have to deal with this. Can't. There we go. Right then. Systemd change default target. Set default multi-user target. There we go. Systemctl set default multi-user target. That will do it then. So systemctl set. Was it hyphenated? Yeah, set default. So we don't have policy kit running, which is why that didn't automatically give me the privilege escalation dialogues. But that's fine. We're deliberately, going light on resources. So our default target is now multi-user, which is fine. But if we look at this, what we're seeing is, although these things will be parallelized, this waiting online thing, there will be services that queue up behind this that are waiting for an online state before they start. So we may be able to get this thing to boot faster if we don't have it wait to be connected to the network. So let's just try it for fun. In fact, what we'll do is we'll reboot with the change that, in fact, I don't need to do that. We'll change this now. We'll disable system. I've never disabled this one before. Network D wait online. All of the different network managers have a wait online equivalent. So that's disabled. Let's reboot.
And let's hope it boots.
What's the worst that could happen? I have no network, but I have access to the console, so it's fine.
It might get stuck in the...
It could take longer. Yeah, it could get tied up. I have noticed that if you have like Samba installed, then things can get wedged behind Samba that's sitting there thinking, where's the network? Right then. So there we go. We're at the login prompt there. So let's come back here and log back in. So let's take a look at how long that took. That's about the same. No significant difference. But let's look at Blame and see if we've broken the process. Oh, that didn't appear to do anything. It doesn't seem to be. I think that may be an internal thing that I have no control over because I didn't see it do anything there. Yeah. So maybe I can't coerce that one. But there we go. And Docker takes 4 seconds. That's fine. Yeah, I forget. I'm thinking about some of the other projects where I have on Raspberry Pi, and I see faster boot times. But of course, I'm forgetting the fact that we have Docker and Containerd coming up in this process. So it's not too shabby, really. I mean, in the great scheme of things, a Raspberry Pi booting, so multi-use target, of course, means that everything's up and we're functioning at that point. Let's just have a quick look at Blame. Again, no, I didn't want to do that. I want to see the dependency tree, just to see what the order looks like. Hello, Nabzo. How you doing there? So let's just take... Oh, in fact, it's not graphical target even. It's multi-user that we're interested in now. Right, let's have a look here. Hey, Tommy. How you doing? Right then. So, Nabzo, let me bring up your question here. So, I'm being asked, do we have Kali Linux on your Raspberry Pi? The answer to that question is no. What we're doing here is we're making our own Ubuntu derivative operating system for the Raspberry Pi that is optimized and tuned to build and run containers. That's the goal here. And I will just bring up my little document here because we've actually done some very simple comparisons. So the proper Ubuntu for the Raspberry Pi requires 2.3 gigabytes for the root file system, whereas ours is 2.1, so not a huge saving, but a saving nonetheless. The default memory utilization of the Ubuntu image is 191 megabytes, and on ours it's 154. And then the default process count is 194, and we've got that down to 138, although I do think we've probably got a bit lower now because we removed a couple of other processes. So let's just do our mega simple check. Oh, hang on, why is that so high? What have I done? 150. Oh, there'll be stuff in here that okay, I can't control all of that. Okay. But that's our footprint, which is looking pretty good to me.
Yeah. For me too.
And if we list the dependencies of the multi-user target, what have we got here? Nothing out of the ordinary. It's all looking just fine. I don't see the network wait online piece anymore now, no, so maybe that has been disabled. Let's try one last reboot. So let's just look at the capture card for the Pi itself so we can track that. Hey Tommy, yeah, it's going pretty well, thanks. I think we're pretty happy with what we've got here. We've definitely made something smaller that uses less RAM and has fewer processes running, but has full-blooded Docker in there, and we even installed some extra bits for Docker as well. So we installed Sift and Grape, and what else do we do? Put the Docker Compose plugin in. So we're just sort of building out like its immediate usefulness. So it's back up. So let's go and log back in. Not great. 141. So that number's way inaccurate. We probably need a better way to actually do that test. But what I care about is everything south of PID 1, and that's looking tidy, really tidy.
Yes, it is.
Now, if we wanted to save a bit of RAM, what we could do is potentially replace our syslogd with the old inetd util syslog daemon, which is tiny, but also comes with the hassle of having to configure the syslog configuration so that it doesn't look like a logging daemon from the 1980s with all of the weird logs that it wants to capture. Tommy asks, can they help in any way? Yeah, pay close attention and tell us where we get it wrong. But actually, I'm pretty happy with what we've got here. Yes, so I'm being asked, are we using Ubuntu Server as a base? Not Ubuntu Server, but Ubuntu, yes. So, Tommy, I know you've seen some of my own personal streams. This script will look familiar, I am sure. It's derived from the script I'm using to make my retro operating system. And if I just get to the bootstrap stage, you will recognize this. We are bootstrapping a base OS, and then we're adding Docker to that and a kernel, and then doing some manipulations in order to, trim it down. So it's the same process, but with a slightly sort of different perspective. And so some of the, decisions that have been made in this script are different, because obviously this is not a retro gaming device, but we've made some similar decisions. So Big Pod, I think if we look at our to-do list, is there anything here we should probably do this, add the user to the Docker group thing, right?
Yeah. And fix the path.
Sorry?
Fix the path.
Yeah, I can't remember how to. Oh, and also the Docker Compose plugin as well. So let's go and do that. That will be in the Docker stage. So Docker gets installed here. And it was Docker Compose plugin, right?
Yes.
And and we've also installed Docker Slim as well, of course. And we're curious here if anyone can help us out. We haven't been able to get access to Docker Scan or Docker SBOM, and we don't know why yet. So if anyone knows why those plugins are unavailable to us, I'd be interested to know. My hunch is I need to authenticate before those become available, which I'm not going to do here right now. But that's my suspicion, but I'm not certain. So let's have a little look here. We go on.
It might be that it's ARM, somehow related to ARM, since I am not authenticated on my desktop and it has Docker scan. But I did install it separately.
Okay. You installed it separately?
Through the Docker scan plugin package in apt.
Really? So I wonder why we're not seeing that.
That package isn't available in ARM apparently.
Okay. Interesting. So I've added our Docker group here. So we create our user in the configuration stage, which comes after I just think I saw something that we need to get rid of. No, it's fine. Which comes after the where we install Docker, and therefore that group gets created. So there's the compose plugin, and the user is now in the right group. So we can get rid of that, and we can get rid of that. We have done that.
I think you removed the wrong thing.
I did remove the wrong thing. Well spotted. So we'll get rid of that, and we've done this. Let's just double check. HCI, yeah, there it is there. So here we will also, so now we can move this Docker Slim piece out. This is cleanup. So that doesn't need to be in this config step because we're doing that further up now. This was just for testing. And installing Dropbear, we're installing earlier up the process. So that's just the Dropbear config. So I think what we'll do here is this. We'll make the system couple set default multi-user target, because we don't care about a graphical environment. We don't have one. The thing we care about is hitting the multi-user target. So I think that concludes this one. The question is, what else? The only thing I can think of is inetd syslogd instead of our syslog, which I tell you what we could do. Without configuring it, we could do the test and see if there's any significant RAM saving, because then we could determine whether it's worth doing. So we could very quickly do this. We can do sudo apt get purge r syslog d. I think is it r syslog. So there we go. That's the package we want. Get rid of that. And then we'll install. Gosh, this is, hanging around in the Linux world for long enough, you get these cobwebs in your brain. So apt search syslogd. I can't remember the exact package name. So here we go. According to the Docker GitHub. So Tommy says, according to the Docker GitHub bomb cli plugin should be a bomb cli plugin.
He corrected himself. SBOM
cli plugin. Okay, let's give that a try. Let's I'll first install this. In fact, I'll show first of all to make sure that doesn't have any recommended packages that are going to cause problems. Invalid show apt show. There we go. Predepends, conflicts, replaces. Okay, that's fine. Let's just install that, and then we're going to follow up on Tommy's suggestion. it's not got Docker in the name at all. It's sbom cli plugin. Nope. Yeah, and Sift because we installed that ourselves using debget. Okay. So I think maybe that's not available for ARM64 or ARM at all. Let's search for Docker and just do that, just out of interest, to see if there's anything that throws up. We've installed that one. Well, there we go.
The only one.
Oh, you need to pull it manually from. You need to pull it manually from GitHub. Okay. Well, I tell you what, that's something to look into. So we'll add that to our little document of things, which is going to be add Docker scan and Docker sbom. Shall we add some of the other scanning tools? Because we've got we could do sift, tree gripe, and there was one other I was thinking of, but I can't remember what it is.
Sneak.
Well, Sneak don't have a deb, so we'd have to go and, grab a tarball like an animal, and I'm not sure I can be bothered with that right now. Yeah. I was just thinking, build out like the basic tools that you would want to have available. I think those are reasonable. Do you think should we include those by default?
I don't know. Probably.
If we get this working, that gives us Sneak, of course. So we decided not to do that because there was no savings. So we're just going to see if doing the syslog thing is going to buy us anything. So did that install earlier?
Yes, it did.
It did. Okay. Let's bounce it. And we'll do a quick memory test at the end. I'd like to think this should move the memory consumption, but our syslog is extremely well architected, and I suspect its default installation doesn't have all of its plugins that can talk to databases and all sorts of exotic endpoints. So I imagine it's actually quite small for a local syslog daemon. So Tommy, you say we need to pull it from GitHub. Looking, can't find anywhere you offers it as a deb. Okay, but we can look into it. We'll look into it. See how it's done. Let's reconnect. And we'll just do 3 -m. Yeah. It hasn't moved things significantly. If it had been significant, it would have been in the 140s, but that's not made any significant difference. So we will not do that change because it is frankly pointless. So we can go and update that and say there is no improvement there. Right, okay. We can't see your link. That's Tommy, are you in our Discord? If you are, paste a link in there, and I'll go and take a look. But I think what we'll do is we've kind of got a good way forward with that. I think.
Yeah.
Thanks, Tommy. That would be good. I'll take a look at that. So, nice one. I'm just gonna have to hop over to here. Cheers. I'm gonna copy that link, and then we'll drop back here and head to a web browser, which is very small. There we go. Let's just. So the plugin for this, here's the releases. So tarballs, okay, and get started. Okay. Interesting, you don't have to do this on an x86 install. Copy that, and let's just try and run it. I'm just curious to see if it's gonna do the right thing.
Yeah.
Uh,
Selected too much.
I was trying not to, but there we go. This isn't going to... Well, might it work? Docker is not installed. Well, that's a lie. Because... There we go. I know for a fact it's definitely installed. So that's going to require some work, I think. You need Docker and Sift. We do have Sift
and
installed
Docker.
and Docker, but actually Sift is not in the path. So let's do this. Let's export path equals path colon user local bin which Sift. There we go. So now let's try that command and see if... No, it's not happy. It's not happy. Docker is not installed. Refusing to install in home Docker CLI plugins. Apt search ply plug. Is that something that we don't have installed? Maybe... Oh, man.
Try Docker plugin install SBOM CLI plugin.
Okay, I will try that. I'm just refreshing my memory on something I looked at here. So Docker C CLI, Docker clean, Docker that's the wrong Docker compose. Docker registry, Docker IO. Okay. No, I'm not seeing... this is installed, which is what I was thinking about.
Yeah.
So your idea was run Docker plugin
Install SBOM CLI.
SBOM CLI, just like that.
Yeah.
Ooh, it thought about it. Insufficient scope. Or may require authorization.
That means it doesn't exist.
Okay. All right. Well, we can dig into this after the fact. So, okay. Well, I'm pretty happy with the outcome, though. We've got an OS. I think what we'll do is I will, sometime tomorrow, I'll push this up to our GitHub repository, maybe with an initial image that, you know, people can download and install on their Raspberry Pis. The other thing that whoops, I'm in the wrong place. Over here. The other thing we could do is, I'm logged in here. If we just go here, reclaim GPU RAM, that's probably the biggest thing that we could do at the moment. It won't have much of an impact on the Pi 4 because of the way that allocates GPU RAM, and we haven't enabled the KMS or anything. But on the Pi 2 and the 3, the compute module 3, Pi 02, we can probably buy back a bit of RAM from the SoC, which would be good to do. So we should definitely look into doing that. But what we can do here is come back down to the bootstrap stage. Go here, clear that, clear, and run for ARM HF. So many passwords on different computers. There we go. So that should work and build a 32-bit ARM version. Now, here is why we might want to do this. You might want this because I'm probably most interested in ARM64 because what we were talking about earlier with so many people having M1 and M2 Macs and that becoming a sort of a commodity architecture now. Hello Mindy, how are you doing? Good to see you again. It's been a while. Hope you're well. But if we use the ARM HF version, because of the way that pointers work in the Raspberry Pi and the memory allocation, you will, for exactly the same software set, this ARM HF version will consume less RAM and less disk. So what will be interesting is like if you've got like a Raspberry Pi 3, for example, or a 2, which only have the top out at 1 gig of RAM, you can actually buy back quite a chunk of RAM on those kinds of Raspberry Pi. So particularly when we look at compute modules and Raspberry Pi Zero, for example, and the Raspberry Pi A models, which have only got either 256 or 512 megs of RAM, maybe running the ARM HF version is what we want, because we don't care about architecture support necessarily. We care about how much stuff can we cram into that small amount of space. Hey Mindy. So Mindy says, I've missed a lot of the retro home streams, so I rewatched them on YouTube this week. Oh right, I'm glad you've enjoyed those. This is in a similar vein because this is using a almost identical technique to make an Ubuntu based operating system for the Raspberry Pi that is optimized for running, making and building containers. So we do actually have a working OS now. It is smaller and more efficient than regular Ubuntu for the Raspberry Pi, and we're just thinking now, as we sort of put a bow on what we've got, what the next steps would be to make this a useful development environment. So Mindy says this is up their alley. I'm glad you think so. If you've got any thoughts and suggestions for how we could make this a more useful dev machine, because that's what I'm hoping is we can actually turn this into a useful tool. Something that Primoz and I were discussing earlier was hooking up Visual Studio Code remote workspaces to it and having it as an endpoint for development. And hey Shock, Shock, I don't recall your username unfortunately, but it's nice to know that we met at KubeCon, so thank you for stopping by and having a look at the sort of stuff that we do here. And Musical Coder says it piques their interest too, as we're looking to deploy Raspberry Pis for scanning and MinerDB API access. What do you mean by scanning? Do you actually mean like scanning documents or digital images or something? I'd be interested to know what you're referring to there in Python. Okay, I'd be interested to know more. And Mindy says, I'm curious how you want to run nspawn through systemd on a CI/CD, since systemd containers don't play particularly nice. Yes, I don't know. It's the answer to that question. Haven't figured that out yet. That feels like a difficult question, although Takov has got some ideas. Unfortunately, he's not here at the moment, but he has some ideas. Right.
It will depend on CI/CD platform you're using.
Yeah, I mean, I don't want to host anything myself.
Builder.
I will have to have a look and see what the options are. But yeah, it's tricky. I mean, maybe we have to augment this to use Docker as the container platform that builds the file system in a container. I don't know how feasible that is. The reason I'm using systemd nspawn is it's really lightweight in the efficient sense of the description, and it's dead reliable. Like, I've been using this technique for some years, and it only went wrong once, and it was user error. Oh, barcode scanning, Musical Coder says. So they say we use barcodes for job information and inventory scanning. So these will actually be physical deployments of a Raspberry Pi connected to a barcode scanner to do scanning with. Interesting. Good stuff. Okay, how are we looking here? Where are we in the build process? It's installing Docker Compose plugin, so we're not far off here. I think if we give this 2 or 3 minutes, we should have an image out the other side, and we could have a go at sticking it on. I'll just grab another SD card. We could boot this ARMHF version. We'll stick it on a 64 gig card to differentiate it from the others, which is going to be slower if I use that one. So actually we'll use one of these ones to keep the speeds comparable. There we go. And then we'll actually see what the RAM saving looks like over the 64-bit version. Hey, Musical Coder, that sounds very interesting. It's a good idea. Oh, I see. Very good.
Not Sheriff.
So thanks Tommy. Depending on lack of motivation. Yeah, anything that you can figure out would be helpful. It would be good to try and get a sort of a complete Docker experience, I suppose, would be the goal. I would like it to feel like you've not made any compromises, that you've got the same sort of developer experience on this as you could get on a let's just call it a PC for simple description's sake. Cheers, Tommy. Yeah, anything you work out, that'll be much appreciated. And Mindy's suggest why my computer's really, the fans are really going at the moment. Mindy says maybe GitHub Actions, for example. Yeah, that's what I'd hoped, but like you say, I don't know enough about what the privilege system is there to know whether if systemd nspawn can run. But it exposes KVM. Oh, okay. Exposes KVM, so we could run QEMU. Okay, so I could use QuickEMU. I could smash together some more projects of mine in order to do this. We can have QuickEMU automatically deploy a VM, and then we step into in fact, that would work, wouldn't it? So providing it can do nested VMs. We could deploy a VM and then step into the VM and then run the containers in VMs, which does work very well because normally I actually have a VM that I run these systemd nspawn builds inside. So where are we? This is the kernel step, so it's very near to completion here, because the config clean and image, they'll whiz by in but a blink of an eye. So yeah, it's just this initial RAM disk baking that is fantastically slow. This is about the only thing that actually has to go through syscall translation, and it's horribly slow. Horribly slow. Oh, there we go. We're just about done. Nearly done. So you've been looking at Nix again, have you, Big Pod?
Yeah, I have it installed for my desktop.
Yeah. Oh, right.
I'm using
Okay.
it right
Yes. Yes. I remember you saying that you were going to do a full install. Is that the same original install that you've still got?
Yeah.
And how's it going?
Okay.
Just okay.
It did make some things easier, must say. I need bridges for my. I have virtual machines running on it,
Right.
and network manager bridging is insanely bad. At random moments, it just disconnects the connection to internet.
Is that that's not a reflection on.
That's not a NixOS. That's on every operating system.
Oh. Okay. So I've managed to overwrite my image with a ARM64 one here because reasons. But I am certain that this is actually an ARM-HF image with the wrong name because of bugs in my script. So I'm just going to write this out and assume that it is indeed an ARM-HF image, and we'll boot the Pi off it and see what happens. So yeah, you're talking about bridge networking there. This is a Nix. Is that a Nix issue or just an issue that you no?
Network manager issue on everything. Just disconnects randomly, and I don't know why, how, anything. And so I set up through proper Nix way through the configuration, no problem at all.
Right.
Normally on Ubuntu, I solve this by using NetPlan and not using Network Manager as renderer.
Yeah. So.
And then it works.
I think Mindy here is kind of identifying the conundrum, and I feel very similarly, which is, wouldn't it be awesome if you could just configure your Debian or Ubuntu system through a declarative configuration? And follow that with, I don't want or need a different distro, but I do want declarative config. Yeah, you can, kind of. It's a very Ubuntu-centric way of doing it using Juju and Charms. But I've been there. I've drunk from those waters. But I agree. I would prefer to stay with the Debian or Ubuntu thing and have all of that power and flexibility of NixOS. But the fact is, Nix was designed to do what it does, and that's what makes it compelling and interesting to me at this time. So I don't know if I would ever step away from Debian and Ubuntu completely, but I definitely want to spend some time to get to know Nix better.
That's why I installed it on my desktop.
Yeah.
Even though everything else will stay Ubuntu. My server, my VMs that I use as servers, and stuff like that.
So, what do you reckon? Do you reckon this is actually an ARM-HF image with the wrong name, or do you think I've just made an ARM64 image again?
I don't know.
Let's have a look. Let's see if there's any clues that we can see. Up here, it's all ARM-HF. It's only the image name that's wrong. So, let's do this. Let's log into the Pi and shut it down. It's enter till dot, isn't it? There we go. That's how you hang up your dead SSH connections. Right, we'll turn the Pi off. We'll plug in the card we've just made. Turn that on. Look at the capture screen and see what happens. I think this text is all going to move too quickly to actually determine what architecture it is, but I think it's probably ARM-HF. So there we go. It's coming up. Yeah, I can't see any of that. It's too small. So so Mindy likes that Ubuntu is backed by a company. Yeah. I'm working on a project in Germany. So an open source, initiative. And they've elected to use OpenSUSE because
That makes sense.
commercial
German.
organization in Germany, right? Yeah. Okay, so let's do this thing where we try to log in. It's got a different IP address again, hasn't it? Okay, let's do NetDiscover and see what's going on.
I bet it's 18.
I think you could be right. It is. Right then, so let's go and log back in here. We're going to have to trash our keys.
Mindy, me and Martin are quite lucky. We can use Ubuntu if we want to, or whatever OS we want to, as our operating systems.
What we're doing now, we're logging in, and the password is test, by the way. Right then, let's just do a quick uname -a. There we go. It is ARMHF, so it's 32-bit ARM. So let's do df-h. So here you can see this is 2.9 gig in size, but that's with our swap file. So our ARMHF file system, let's just make sure all the same stuff is running. It is. There's Docker and Containerd. All of the same stuff is working, but our file system is 1.9 gig. So if we just go back here, we have knocked another 200 meg off. So this is where, the difference between 64-bit ARM can really, pay dividends. So if we do a look at RAM, we're down to 91 meg. Just by changing architecture. So this is all the same stuff. Now down to 91 meg. So that's quite the saving, and the process count should be similar. And in fact, this is a horribly inaccurate way of counting processes. So I will need to come up with a better solution. But it says 140, but I don't. Yeah, it's that, and that's equivalent to this. So we just need a better metric. But there we go. That's quite the difference there. In fact, that's 100 meg. Look, by switching architectures and trimming down the OS. So there's something to consider if you're, playing around with ARM and you're resource constrained. Switching to ARM32 can pay off quite considerably.
I honestly think that we will start to see more powerful processors, powerful ARM processors.
Yeah.
I think in a year or two, we will see 16 gigs, many cores.
Yeah, I mean, they are out there.
That's it's only proliferated because M1 showed what it can do.
Yeah, the thing about M1 is it's not ARM. It's not just ARM. ARM is the CPU complex, but there's so much more on their chips. Their AI engine, their media engine, they're putting the RAM on, the memory controller, everything integrated there. It's a GPU.
It's an SoC.
Design. Yeah, but so much more than just a regular ARM SoC. So, but I think you're right. Intel have still got ARM licenses. AMD are saying they're working on ARM chips.
And I bet Intel has
right.
something in the back pocket if they need to, because they would be crazy if they didn't develop ARM chip during their horrible time with 14 nanometers. Yeah,
indeed. Hey Pete, how you doing? So Pete, PSV in the chat there is one of our colleagues. Pete, who I quite often stream with. So Pete, we've made an operating system for 32-bit ARM and 64-bit ARM, and it's got Docker and all the Docker tools pre-installed. It's super trim. So we can do docker pull hello world, if we can spell it correctly, And there we go. Docker run IT hello world. And this OS is actually 32-bit ARM. There we go. It tells us so here. Look at that. And what I was just demonstrating is what a difference using 32-bit ARM over 64-bit ARM can make. So this is the official Ubuntu metrics. It's a 2.3 gigabyte file system. Our equivalent is, and this is 64-bit ARM, was 2.1. But switching to 32-bit ARM, we brought that down to 1.9. But this is where the big savings come in. We've shaved about 40 meg off the running process count, but if you switch to 32-bit ARM, we can run the whole system with Dockerd and Containerd all preloaded, configured and ready to go and running in 91 meg of RAM. So we're pretty happy with how this is shaping up here, and so I think we're at a point where it's in a pretty good place, and we've even done a few bits here where we have in fact, I'm going to have to do this like an animal because this is a bug we haven't fixed yet. We've got Docker Slim pre-installed, he says. Oh, hello. Oh.
It didn't install.
It didn't install. Well, that's curious. It didn't install anything at all that we asked. That's curious. Well, there's a bug to look into. It works on 64-bit ARM, but not 32-bit ARM. So that may be why the file system looks so much smaller, because some things have not been installed. Okay, well, there we go. That's a little problem for next time. But I think where we're going to take this, and in fact, I'll just move this to a big view of us, is we have this pretty much pinned down, and so the next thing to do is to go through the same process but make our own super trim base images in a similar way. So can we take, or not even take, can we make an Ubuntu derived base image for ARM64 and ARM32 that are measurably and significantly smaller in terms of root file system size and memory consumption, although that's difficult because we won't actually have a common process to launch, so we just have to go for smaller. And then what we should do is put like a sample app inside that and do a security scan of those things. And then Pete, what we're thinking is now we have these abilities. Primoz and I are going to look at how you could use this as like a dev machine with VS Code remote, and prepare a container that maybe I could send to you, and you can run the container that I have built on my Raspberry Pi on your M1 Mac. That's sort of where we're going with this. This a way to interchange projects on ARM from different platforms. Yes, the Tegra is still going strong in the Switch. It was ahead of its time, that one, I think. And so Mindy says the Slim.AI base image sounds counterintuitive because of the whole premise of Docker Slim. I'll explain. I'll just finish reading your message. To rip everything out, you don't want early optimization. So the reason for this idea is we're experimenting with some different approaches to optimizing containers. And one of the ideas that we talked about was starting with something much smaller and tipping the whole optimization process on its head and having an additive process. Because if we analyze a container and we know what needs to be removed, we also know what needs to be preserved. So what if we started with a smaller base image and just added the bits to it that it needs in order to run? So this is pure science lab experiment time, but it's an opportunity to sort of test the waters with those ideas and just see what we can make with this. And also, starting with a smaller base image, it is possible that your optimization process will run a bit quicker as well. So it's all about like momentum. If you've got a smaller base image, that iteration development time will be faster. So some of those efficiencies pay dividends there as well.
And sometimes people don't want to optimize everything away.
Right.
Because, well, it might not be as stable, or they might have a lot of problems with that, since their applications could be highly tied into many things, and they might not be detected by any kind of standard detection tool we have.
And you know, well anyway, we will have an experiment, but we will see where it leads. But hopefully tomorrow, if Pete's still listening, Pete, could you make me an admin on the SlimDevOps GitHub organization, please? And then I can throw what we've created here into GitHub, and when we put these videos live, we can have links to the source code. And what I'm thinking is maybe tomorrow morning I'll polish these up, clean up the little rough edges with for whatever reason things being missed in the ARM version. And maybe get a couple of images published onto GitHub as well, so people can actually download these things and test them on their Raspberry Pis. Cheers, Pete. Thanks a lot. So I've been looking to see if friends of Slim are doing any streaming, and I don't see anyone, and I don't see any other familiar faces that are streaming at the moment either. So I don't think I'm going to go raiding, because I'm not familiar with the people that are streaming at this time of day, and I don't want to make a bad choice. So I think we will put a bow on it there. So thank you very much for those of you that stopped by. Thanks for your help and encouragement along the way. I hope you found that interesting. I like the last bit where you run the 32-bit version and you buy back gobs of memory. That's always good fun. So sometimes progress isn't always a good thing. Who needs a package manager when you can run it in Docker? Well, indeed.
Progress of ARM64 came because there is more RAM, and in a 32-bit RAM you can't run anything more than 4 gigs.
Yep, indeed. But you know, if you don't need well, like on a Raspberry Pi 3, you've got a 1 gig ceiling, so you're probably best off sticking with the 32-bit version to make the most of the memory that you do have available there. So that was kind of my thinking behind making both versions. I would probably mostly use ARM64 because, like we were saying earlier, that's become a commodity architecture because of the M1 the Apple Silicon. Right then, well, thank you everyone. We will be back next week. I think we might do more of these like double header type things to catch like the early crowd in the morning and our regular slot in the evening, when we're doing these sort of, you know, how hard can it be sort of challenges type things, where we've got a beefier subject we want to dive into. So we might do that, and maybe we'll spread them around the week a little bit. But thanks very much, everyone. I hope you enjoyed that. Comments and feedback welcome in Discord, and you can find links to that above my head. Anything to add, Primoz?
No.
Okay. Right. Well, thank you, everyone. I look forward to seeing you soon, and let us know what the next experiment could be. You've got a flavour of where we're going, but see you soon. Bye bye for now.